Yes, Colby? Yep, end of class. Or once we're done the lesson. Okay, so parallel lines are lines that do not cross. So for an example, you can do just a mini graph. It doesn't have to be perfect. For instance, those are two parallel lines. So let you copy that first, then we'll talk about it. So parallel lines have the same a value or rate of change slope. So that's your y2 minus y1 over x2 minus x1. They're the same because if you actually look at the slope, it's not changing. The steepness of the lines doesn't change. It's the exact same. So you have your two lines here. There's two types of parallel lines that we're going to deal with. And we'll talk about both. We're just going to give yourself a bit of room. Parallel and coincident, and parallel and distinct. So we'll talk about what each of those terms mean. This is something that would go on a memory aid. It's not something that you need to memorize. This is definitely something that goes on a memory aid, though. Only because those terms can come up in a multiple choice. Doesn't mean they will ask you, but I have seen it on different exams, and they'll definitely be on either a quiz or a test or something that I ask you for. So parallel and coincident. They have the same a value, so both lines, because we're dealing with two lines when we talk about parallel lines. You could have two or more, but really this year we're just dealing with two lines that are parallel. So it means that they have the same slope, which we just covered, but they also have the same b. Because remember, a line looks like this. So if they're parallel, they share the same a, and if they're parallel and coincident, they actually have the same b as well. So this graph looks something like this. Let's say we have one line like that. So yeah, perfect for this. And then if we had a second line, it would actually, so I'm using a highlighter, go right over top. Still two lines. So the question I always get every year is, well, if they're the exact same line, then isn't it just one line? But it could be something like, if it's underneath. See that, the line that's in pen and then the highlighter? So if they're parallel and coincident, they actually fall on top of each other. If you think about it, so
Did you use like blue or green or something?
Blue underneath and green over top in your
I see.
color. Yes, okay,
Yeah, no,
got it.
no.
Okay, so the idea is that in this case, it could be something like if we're dealing with Bell and Rogers. two big telephone companies, so let's say cell phones, they basically charge the same thing. They might have deals and everything, but let's just say their basic plans are the same. So that blue line could be Bell and the green line is Rogers. So they charge the same, so they fall on top of each other, but they're two different companies. So that's why they're parallel and coincident. So it's not the same company twice, it's two different ones. They just fall on top of each other. Parallel and distinct then. Again, since they're parallel, they have the same slopes. That does not change. And I label them line 1, line 2 to make it easier. Just whatever line you're dealing with first and then the second. This part here, same slopes. But now instead of having the same B, they do not equal each other. And if we're a mini graph for this one, just like before, maybe I'll do one in green so you can see the two different ones. That should just be green. Let's erase that and just do it in green. There you go. So you can see they either fall on top of each other or they're separate. When they're separate, it means that their B's are different, they're parallel and distinct. And for an analogy for that one, you could think about gym memberships. So two big gyms in Ontario, so Good Life and Movati. Well, Good Life and Movati actually have pretty much the same monthly fees, but to join Good Life is actually cheaper. Just the initial cost, not after that. After that, they pretty much charge $50 to $80 a month.
A month?
Yeah.
I was saying, if you're going every day, then it's not.
No,
I watch Netflix every day and it only costs me $15.
CrossFit gyms are about $150 a month. Yeah. Yep.
Just run in your yard.
The one's in Ottawa.
Yeah.
Oh, in Ottawa, yeah.
There could be one that's cheaper here.
Run away from the police.
Where?
Yeah, but like free.
I know the ones, the three big ones in Ottawa are $150 a month. Actually, $189 for one of them. All right. So bring it back. So parallel, coincident, again, same A's. Parallel, distinct, still same A's because they're parallel. Parallel lines both have the same A's. The difference is if they have the same B, they fall on top of each other. If they're different, then it's two distinct lines. Okay, this is not a memorization. This is, you can have a memory aid and write these terms on there. You just need to make sure to decide whether they are parallel, whether they're parallel coincident, parallel distinct. So we're going to go through an example now.
So many words and so little to make sense.
It's because we just learned it, so it's going to take some time. Okay, so we wrote it down, so let's go through example 1. And we're going to go through it together. Remember, parallel and perpendicular lines this week, the 2 lessons I'm teaching you, are tough. They're probably the tougher lessons that you'll learn all year. Okay, example 1. He might have talked, or she, depending who you had, sorry, might have talked about parallel lines, but not to this extent, no. You might be thinking direct and indirect.
Probably.
Yeah, which is whether it goes through the origin or not. Which does have to do with your B value, so if it doesn't have a B value, it goes through the origin, and if it does, then it's up higher. So there's a lot of similarities. State whether the following is parallel and coincident. Oh, I'm running out of room, so I think you get that, okay? 2, parallel and distinct, or 3 neither, or none of the above? Mateo, should be writing this, please. Okay, so again, see whether the following is parallel, coincident, parallel, distinct, or neither. So this is getting close to 4-mark questions or multiple choice we'd see on an exam. The only other fourth option, A, B, C, D, would be perpendicular, which I'm teaching you on Wednesday. So until then, these are the 3 options we have. So let's go through A. Copy it down, don't shout it out if you think you know it. Not yet. We're gonna walk you through this one. Okay, so to decide if they're parallel, what's the letter that they have in common? Or what's the thing that they have in common? That's the exact same. Which value? The A, which is the 2. Perfect. So what we have to do is look first to see if they're parallel. That's the first thing that you should check for. Because if they're not parallel, then that's easy. They're neither. So what we're going to do is we're going to look through the first one. And the A is always beside the X. We were taught that last year. The A is always beside the X. So if I look at the first one, it's 2. If I look at the second one, it's also 2. So first, are they parallel? Yes, they are parallel. So we're going to write parallel. Now we have to decide then if they have the same B or different B's. So look at the number beside it. So these are the A's. Perfect. And the B's you can tell are different, so therefore it's parallel and distinct. Perfect. Done. Mateo, head up. Thank you. No, head right off your desk so you don't fall asleep, okay? Thank you. Try. Okay. All right, so let's go through B. Nope. In this case, we don't solve for anything. We will start to kind of rearrange it shortly. Well, once B gets a little bit harder, C gets tough. So let's go through B.
Sense of security. They're lying to us.
Okay, let's look through this one. First, let's call this the first line. Let's call this the second line. What's my A1 in this case for the first one? What is the A in this first one? Just look at the first, like the one that I'm circling. What's the A? 3. Or 3x if you want to write the x beside it, because I know last year that happened a lot. What's the second one? What's the A in this one? 3x. It's always the number beside the x. So are they parallel?
No, they're coincident.
They're parallel and coincident. What's the B here? -2. What's the B here? -2 or -2. So it is going to be parallel and coincident because they share everything. It's just I wrote it in reverse. That's okay. But see how the 3's are the same? See how the -2's are the same? It doesn't matter which order it's written. As long as the 3's are the same and the B's are the same, then they are the same. Do you notice how this is a negative, this is a negative? Because -2 is a lot different than +2. If you're thinking like weather-wise, that's different. +2 is much nicer than -2 when the water freezes. And if you're a golfer, -2 is nicer than +2. So there is a huge difference. If you're not a golfer, it wouldn't make sense. So.
No. It made sense because we did frisbee golf.
Oh, okay. Okay, A, B, and then C. This is the tougher one. So let's do the slightly tougher one.
No.
Okay,
I understand so far. Let's not lose that.
just write it and I'll walk you through this one because this one's a little bit
That's not that
different. No. There's one step before we actually figure out if they're parallel though. Okay?
What?
There's a reason why I got you to rearrange equations at the very beginning of the year. So I got you to rearrange equations to
Oh, I
get
know this.
y by itself. What would you do first?
Well, I'd move the y to the other side and the 2 to this side, which makes it -2.
But this becomes a negative y.
I put -2x on
There
the
you
other
go.
side.
Okay, so the first step you have to do, see how these had the y completely alone, positive, no number attached to it, nothing? You can't actually figure out if parallel lines are parallel unless it is in this form. So a note here, I'll do it in red so you know that this is really important. You have to rearrange the equation every time to get y by itself. If it's already by itself, wicked. Bruno, can you put the phone away? Thank you.
And so there you get -2, the y equals 2 minus 2r. So it would not be a parallel.
Exactly, because right now it looks parallel and it looks coincident, but it's not because, yeah. So when you move the 2x over, I cross an equal sign, what's it become? Perfect.
How does everyone say negative? I think minus.
I interchange between the two, so it's okay. So if you look at it now, your A1 is -2, right? The number beside the x. And your A2 is +2. So remember what I just said about the positive and negative. They are different. So therefore it is neither, because we don't even care about the b at that point, because as soon as the a's aren't the same, this one line is going in this direction, that line is going in that direction. They are definitely not parallel. They cross each other. So they are neither. Good so far? Okay. Yes, Colby? Yeah. Okay. So again, this would be similar to a multiple choice that you'd see. The biggest part is the rearranging. Students sometimes forget that, and then you could lose 4 marks. So like most of the examples I do before the quizzes, I'm going to do where you have to rearrange it to remind you. And there's no quiz this week. It's next week.
Why not, miss? We can do it online. No, we can do it Friday.
It's kind of why.
Online.
I will explain the schedule shortly.
Or just not do it.
Okay, the next part. This is the harder part. So that part was okay. I think if we practiced it, you guys would be fine. It's going to be the second part that's a little bit trickier. Okay, so if we have 2 lines and they're parallel. So if we have 2 lines and they are parallel, if we know the rule for one of them and a point on the second, we can get the second rule. It's a lot of words there, but I'm leading up to how we're actually going to solve this. So don't worry if this looks a little confusing. It's more just a lead into how we're actually going to start solving. Yes. Yep. So this is our second example. I'll let you copy it first, then we're gonna go through the steps. Okay, so again, find the rule of a line parallel to y equals 5x plus 2. So we have one line right now. We want to find a second line that's parallel to it. But it can't just be any line. It has to be a specific one that goes through 1 and 4. So what we're looking for, I'm going to show you the diagram. You don't need to write this. I'm just showing you like a visual because they don't always have a visual for these things. But I'm going to show you. For instance, if I had the first one, if this is the first line, they're looking for a second one that roughly goes through, let's say, 2. They're looking for a second line that goes through point 1 and 4. Okay, so they're not just looking for any parallel line. Those would be more straight. I didn't use a ruler, sorry. But you get the idea that they're not looking for just any parallel line, because then you can just basically make up any B that you want. They're looking for a specific one that goes through that point. So they're looking for the rule of that line that goes through it that's parallel. So now that you kind of get, hopefully, like a visual for it, we don't actually do the diagram. You won't have to graph these. We're not graphing stuff until about January. So I'm going to get rid of that for now because we're not actually using that. I know, but I just don't want to confuse with the stuff I'm about to write because it gets a lot. It gets a lot of stuff. Okay, the steps. Sam, just. Okay, my steps. So I go through 3 different steps. They're not official steps to solve these, but I found before I had steps, a lot of my students did really bad on these questions. When I started introducing the 3 steps, my students went from getting like 4 out of 10 as an average to like 8 out of 10 as the average. Because it is a tough question, it's very hard to get the 10 out of 10. A lot of calculation errors happen, things like that. So I want to go through the steps. These are steps that are going to be something I'd suggest writing on a memory aid. And also good for perpendicular lines. So step 1 is to get your A1. So we talked about 2 lines. A1 means line 1. The A for line 1, kind of like we did last time where you got your A. This will either be, it's either given or you have to calculate it. And how you calculate it is reaching back to what we did before. Like I said, this comes back. It comes back definitely this week. So it's either given. If it's given, so much easier. If it's not given, you have to calculate it. So in the example I give you, I give it to you. So let's just focus on step 1 to get our A1. What's our A1? For the only thing that we're given in this question. Sorry? What's the actual number? 5x. Perfect. So the actual A1 in the example here, I'll do it in blue so you can see I'm going back to the example. My first one is given to me. It's the 5x. It's the number beside the x, so that 5 is really important. So for parallel lines, my A1 is actually given, even easier. If it isn't, I'd have to give you 2 coordinates and you have to calculate it. So it takes a little bit longer. But in this case, it's given. The calculation one is the example I'm going to use tomorrow when we go virtual. Let's do step 2. That's it for step 1. A2. So A1 is given or you calculate it. A2 because these three steps are also going to follow us to perpendicular lines, we use A1 to get A2 in both cases. So for parallel, it's even easier, because if I know A1 and I know they're parallel, what would be my A2 in this case? My A1 is 5. What about A2? 5. Perfect. So if you did this on a test or a quiz, you actually, if this is a 10-mark question, you actually would get 4 marks. You get 4 marks because you're telling me you understand parallel lines have the same A value. So A1 equals 5, A2 equals 5. Perfect. They're parallel. They're the same. It seems repetitive to write it, but you have to write it. You have to say A1 is 5. My A2 for the second line is also 5. Because you're telling me, I understand, they have the same A. Let's do step 3. This is our last step. We're dealing with the second line right now. This is the first line. We want to find the second line. So my first line was really only good for the A value. That's pretty much the case every time. Your first line is only going to be good for the A. Then after that, we just switch right to the second line. So my second line, or my B2, you need to recalculate. You can't just take this 2, because it may not be 2. It may not be coincident. It may not be the same line. It could be different. So you always have to recalculate the B. This is important. Because that doesn't always happen. You get some marks off, you still get part marks. And you're going to use this formula. That should just be a minus. I don't know why I went to put another equals.
I think you're underlining it.
As I wrote it. And why? It's because that's the part that students forget.
Y equals AX?
Minus AX. Yeah, I don't know if I put 2 equals. I think I'm used to writing Y equals AX plus B. So. Okay, we're going to recalculate the B using a point on line 2, because sometimes they'll give you a point on line 1 still, and then students grab that and use that. But if I'm looking for my second line, I have to use a point that's on my second line. Again, if this looks confusing, it's because the first time you're being taught it. It's not meant to be super easy right away. We're going to go through another example after this.
I mean, if you know both A's are parallel, isn't it just a 50-50 answer that point?
Well, no, because you still have to calculate the B. We don't know what the B is.
Well, it's a gamble between coincidence and the other one.
Yeah, but if it's distinct, it's not 50-50. It's one line versus a whole bunch of lines. Yeah. Yes. Yeah. So my B is going to be, now we're going back up to the example, right, in blue. So if it goes through point 1 and 4, that's the one thing we didn't use. We already used this. Now let's calculate the 4 and 1. So what's my Y in this case? It's 4, right? Okay, minus, what's my A? 5, perfect. And then what's my X? Perfect.
All right, I would not have done that.
And if you want to be even better with these steps, here's the other thing that you can do for the B. A2, because for perpendicular lines, it's not the same. So you always have to use the second A. In this case, they're both 5, so you could just grab a 5 and you're fine. But for perpendicular lines, because there's a difference, this is what I'd probably add to it, so you know which A to take. So then we go 4 minus 5, which is equal to -1. So then I have, therefore, my answer is Y equals 5x minus 1. Yeah. -1.
Oh,
You switched it.
switching up on myself, man.
Okay, so that is, we're gonna go through, I think, one more example. Is it 32 or 42 that we had? So we're gonna go through one more example. I'm just gonna leave
And
you.
it's 40 minutes.
No, we technically end at 42 because Kathy ends at 40 when we get out at 40.
But I stop